Welcome back. In this video, we're going to look at factoring a particular type of trinomial that looks like this. Wait a minute, you might be thinking. That's not a trinomial, it's a binomial. And you'd be correct. But as we'll see, the key to understanding how to factor this binomial is to think of it as a trinomial. This type of expression is known as a difference of squares. Difference because we're subtracting. Squares because our two terms are perfect squares. So how can we factor this expression? We could try common factoring, but that doesn't get us anywhere here. Notice that this expression has an x squared term and a constant term, but it's missing the x term that we're used to seeing in our trinomials. We can write in an x term. If we add 0x in our expression, we're not actually adding anything, but now the expression looks like the trinomials we're used to, one of the nice ones where the coefficient of x squared is 1. So, to factor this trinomial, we just need to find two numbers that multiply to negative 25 and add to 0. These numbers are 5 and negative 5, and therefore our factors are x plus 5 and x minus 5. Let's quickly analyze our result here to see how we can apply it to the factorization of other differences of squares. First, notice that our two factors involve the opposite operations of addition and subtraction. Also notice that the value we're adding and subtracting is the same in each factor, and it's the square root of the 25 in our original expression. All of these elements play a role in guaranteeing that if we expanded the factored expression, we'd get a 1x squared term, a constant term of negative 25, and no x term. I encourage you to try expanding our factored expression here to see what happens. It's also worth noting the significance of having a difference of squares. If instead we started with a sum of squares, we could not factor the expression like this, since we wouldn't be able to find two numbers that multiply to positive 25 and add to 0. Let's try using these ideas to factor some other expressions. X squared minus 9 is a difference of squares, and the square root of 9 is 3. Therefore, in factored form, this expression is x plus 3 times x minus 3. Similarly, x squared minus 121 is a difference of squares. Since the square root of 121 is 11, our factors are x plus 11 and x minus 11. Using similar reasoning, we can factor differences of squares in which the coefficient of x squared is not 1, but rather any perfect square. For example, let's consider the expression 4x squared minus 49. This expression is indeed a difference of squares, since we're subtracting 49, which is 7 times itself, from 4x squared, which is 2x times itself. So the factored form of this expression is 2x plus 7 times 2x minus 7. If you're uncertain about this result, try expanding this factored expression to see how it gives the original expression. 81x squared minus 16 is another difference of squares. Since the square root of 81 is 9 and the square root of 16 is 4, the factored version of this expression is 9x plus 4 times 9x minus 4. What about 2x squared minus 72? 2 and 72 are not perfect squares, so where do we go from here? Well, remember that whenever we factor an expression, we should try to common factor first. Since the greatest common factor of 2 and 72 is 2, we can common factor out a 2, leaving us with x squared minus 36, which is, you guessed it, a difference of squares. So the fully factored expression is 2 times x plus 6 times x minus 6. Let's do one more. Negative 48x squared plus 75. This expression doesn't appear to have anything to do with a difference of squares since it's written as a sum, and furthermore, 48 and 75 are not perfect squares. Once again, let's start by attempting to common factor. The greatest common factor of 48 and 75 is 3, but since the x squared term has a negative coefficient, we'll factor out a negative 3, leaving us with 16x squared minus 25, which is a difference of squares. The factors of this difference of squares are 4x plus 5 and 4x minus 5, which along with the common factor of negative 3 give us the fully factored expression. For loads of interactive practice exercises on factoring differences of squares, check out the links in this video's description.